When we take an AI out of a simple text-based chat interface and drop it into a multi-layered, three-dimensional digital workspace, its performance fractures. Basic agentic architectures have already mastered short-horizon, isolated tasks. If you look at legacy benchmarks like Web Arena, these models perform quite well. But put those exact same agents inside proprietary, professional software like Siemens NX or Unreal Engine, and they immediately break down. Operating in these environments requires completing a long horizon workflow. The agent cannot rely on a single prompt and response. It has to make a series of compounding, state-dependent decisions. To measure the actual economic value of an AI agent, we have to evaluate it strictly within these unforgiving real-world software constraints. The structural solution to this evaluation gap is Agent's Last Exam, a project led by UC Berkeley RDI. This is a massive evaluation framework, explicitly designed to cover 55 distinct professional sub-industries. The researchers have already gathered over 1,500 verified workflows, and they are actively expanding toward a target of 5,000 tasks. This coverage maps a significant cross-section of professional computer-based work, from engineering to visual effects. By aggregating thousands of specific workflows, this project moves AI evaluation away from subjective anecdotal testing and establishes a hard industrial-scale metric. There is an architectural challenge in scaling this kind of test. You can't use a generic large language model as a judge to verify specialized engineering output. Subjective grading fails at this scale. Instead, the benchmark relies on hard objective success criteria defined entirely by humans. To build that grading rubric, the project depends on a coalition of more than 300 domain experts who co-lead and advise on the specific success criteria. Establishing this standard across so many disciplines requires academic consensus. The advisory committee expands across global institutions, bringing in domain specialists from universities worldwide to validate the tasks. It also draws on major industry partners, including Goldman Sachs, Adobe, and Oracle, who contribute directly to these workflow standards. Robust, long-horizon evaluation requires this massive consensus of human expertise before the AI even attempts its first task. Let's look inside specific software environments to see exactly how these expert rubrics operate in practice. In manufacturing, an agent might be assigned a mold flow analysis task. It must navigate the MoldX 3D interface, managing software dependencies. It runs an exact sequence of parameters. A single early error corrupts the final analysis. We see similar constraints in architecture, where the agent is evaluated on 3D modeling workflows in Rhino 3D. This requires managing high contextual complexity, like performing an energy analysis for an urban design project located in Zurich. Success in these environments is not measured by a text-based output. It is a structural, verifiable alteration of the proprietary software state. We see this same demand for precision in the neuroscience domain, specifically when using specialized software like FSLIs. Here, the challenge involves executing a detailed neuroimaging analysis and isolating brain structure segmentation. This split screen shows the difference. Standard benchmarks evaluate by asking multiple choice questions. Agent's Last Exam verifies it directly within the workspace. The rubric mathematically checks the visual layer and metadata to confirm perfectly precise segmentation. A verifiable outcome demands undeniable, objective proof that the agent matched the exact end state demanded by the domain expert. This raises a structural question. How do you rank an AI on a single leaderboard when it is performing game development in Unreal Engine 1 minute and visual effects in After Effects the next? This data visualization illustrates the project's unified leaderboard. It utilizes an algorithm that aggregates scores from varying industries and normalizes them into a single, standardized ranking vector. This aggregation ensures the scores remain directly comparable and meaningful, regardless of the underlying software complexity. By normalizing these disparate tasks, the benchmark creates a true cross-domain metric for measuring the economic utility of AI agents. Agent's Last Exam is an open, continuously evolving research project that is actively expanding its dataset. The team is inviting researchers and domain experts to submit their own workflow data to the system. High-impact contributions qualify for co-authorship on the resulting manuscript, as well as access to a funding pool of over $100,000. As the dataset grows towards its 5,000 task target, it creates a high-resolution map for agent evaluation across these domains. Standardizing how we evaluate these systems is a collective, industry-wide imperative for developing agents that function reliably in the real economy.